Alright, in this video we're going to talk about measuring distances in R3, and then we'll solve question 8 on the worksheet. Alright, so let's say we have 2 points P and Q in R3, and I'll label the coordinates of P as x1, y1, z1, and the coordinates of Q as x2, y2, z2. And our job is to find an expression in terms of these coordinates that tell us the distance between these 2 points. Okay, so let's say we start at P, and we want to move to Q, right? And we'll begin by moving parallel to the x-axis. Okay, and we're going to have to move a distance that's equal to the difference in the x-coordinates of these 2 points. So in other words, this distance here in purple is equal to x2 minus x1. Okay, then we'll move parallel to the y-axis. We'll have to move a distance that's equal to the difference in the y-coordinates, so y2 minus y1. And then finally we'll move parallel to the z-axis, and that's a distance of z2 minus z1. Okay, so now consider this right triangle here that's parallel to the xy plane. Okay, and I've copied that triangle over here. And note that the hypotenuse of this triangle, right, the length of this segment from P to this point I've labeled as R, is equal to the square root of the sum of the squares of these 2 legs. Okay, now with that in mind, consider this right triangle. Okay, so I've copied this triangle over here, and note that its hypotenuse in red here is the distance we're looking for. It's the distance from P to Q. And the base of this triangle is this yellow distance here. I've copied that here. And then the height of the triangle, right, that's this length in orange, right, which is just z2 minus z1. Okay, so now to find this distance from P to Q, just apply the Pythagorean theorem again. Right, so the sum of the squares of these 2 legs under a square root is equal to the hypotenuse of this triangle, right? So if I square this square root and then I add to it the square of this expression, I'm going to get what you see here, and then apply the square root to find the length of the hypotenuse. Okay, so this is the distance formula in R3. All right, now note here that this distance is equal to the length of the vector PQ, right, whose tail is at P and whose tip is at Q. And we actually noted this in an earlier video. Cool. All right, now with all that in place, let's check out question 8 on the worksheet. All right, so it says, find the lengths of the triangle PQR, I've drawn PQR here, where the coordinates of P are 2, negative 1, 0, the coordinates of Q are 4, 1, 1, and the coordinates of R are 4, negative 5, 4. And then it asks, is this a right triangle? Okay, well, I'll go ahead and find first PQ as a vector, right? So the vector whose tail is at P and whose tip is at Q, because as we just noted, the magnitude of that vector is the distance from the point P to the point Q. Okay, so now to find this vector PQ, remember you just subtract coordinate-wise, right? So for the I component of PQ, you take the x coordinate of Q and subtract from it the x coordinate of P. So 4 minus 2 is 2I. Then for the j component, 1 minus a negative 1, that'd be a positive 2j. And then for the k component, 1 minus 0, that's 1k. So the magnitude of this vector PQ, that's the square root of 2 squared plus 2 squared plus 1 squared. That's the root of 9, which is equal to 3. Okay, so the distance from the point P to the point Q is equal to 3. All right, then likewise QR, this is the vector negative 6j plus 3k. And note here, I can factor out a 3. So to find the magnitude of the vector QR, that's going to be 3 times the magnitude of this vector, negative 2j plus k. So that's the root of negative 2 squared plus 1 squared. So that all comes out to be 3 root 5. So the distance from the point Q to the point R is 3 root 5. Okay, and then lastly, the vector PR, this is 2i minus 4j plus 4k. So here I'll factor out a 2. And then to find the magnitude of the vector PR, this is going to be 2 times the root of 1 squared plus negative 2 squared plus 2 squared, and that simplifies to 6. So the distance from P to R is 6. All right, so now it asks, is this a right triangle? Well, to answer that, what we'd like to know is, do the sides satisfy the Pythagorean theorem? Okay, well, first note that the long side here in the triangle is, right, the distance from Q to R, right? Because the magnitude of the vector QR, that's 3 root 5. So that's the longest side. So if this is, in fact, a right triangle, the side from Q to R will have to be the hypotenuse, right? So is, right, the magnitude of the vector QR squared equal to the sum of the squares of these other two smaller sides? Well, in this case, the answer is yes, right? Because if I square 3 root 5, well, I get 45. And then squaring these other two sides, I'm going to get a 9 and a 36. So the answer there is yes. All right. So that does it for this question. And I'll see you in the next video. Thanks so much.